Okay. My comment is that, clearly did this in class last time, and less than a third of the class knew this. Okay. A to the negative b is 1 over a to the b is 1 of your rules of exponents. You had an assignment on exponents. Okay. This is one of your rules. Okay. Not sure that rule was in the assignment, but it goes along with all the other rules. And if you don't know this, it means that you didn't properly do that assignment. Okay. And you have to do the assignments properly. And review what you do. You work on it until you understand it. Okay. Because as I said before, we're laying the basis for the whole course already. You need this in order to evaluate some of your basic functions, which are the key, the core, the heart of the course. And you do real well with this. A lot of people did pretty well. If you didn't know that you start this process, with this table, well, ask yourself why. Okay, we did it in class last time. And again, I recommend looking through, making sure you recognize everything, making sure if there's something that you thought you knew when you were in class, but all of a sudden, you're not sure you know, put it in your notes and use it and learn it. Okay. And what do we do? We put 2 here, and we put -2 here. And we cut this interval from 0 to 2 in half, and that's where 1 is. And then the interval from 0 to 1 in half, and that's where 1/2 is. And if we needed it, we could cut that in half and get 1/4. These marks are not equally spaced. Okay? Every one of them is further from the other from the last one. And if you don't do this, chances are you're going to get a really bad looking graph. Okay. So we do the same thing here. And then we know that 4 goes up here for the basic exponential function. Because the second is 4. That's the biggest value we get. So then we cut the value down. We need 2. We need 1. We need 1/2, and we need 1/4. Now, I'm not going to do this again. Right there in the video, you can access it. Okay. And you should be able to come in here. It's not a difficult process. If you didn't master it, you're not ready to go on. Well, you get ready to go on, you get it down by Thursday, you'll be okay. But you're not oriented to the course. You don't understand these functions, okay? You have to understand these functions. You have to understand the arithmetic, etc. Okay, well, also, on the homework, I believe, actually, that might have been homework for different courses, maybe. But I told you what the names of these things are. If you didn't know the names, you didn't properly review. Okay? Some of you did, a significant number of you did, but most of you didn't. So I'm not being accusatory. I'm simply telling you what it takes to pass this course. You got to up your game. Most of you need to up your game a little bit. And sometimes just a little bit, sometimes a little bit more. But whatever it is, do it. Let me just take a quick look here. And as of like 9:30 this morning, only half the class had even submitted this assignment. Now, everybody else might have, done it in that last hour or so. I haven't been able to look, but if you didn't do it, I just have to say, what are you thinking? This is a college course. It's assigned, you do it, okay? Now, maybe you get sick, maybe you have a car accident, maybe something happens, and you got to make it up. But short of things like that, you do it. Okay. It could be some of you did it and didn't know how to scan your document or take a picture, didn't have a camera handy or whatever, which is why I made it due a day later than I originally did, so you go to the scanners in the library, okay? So make sure you're on top of these things. Just the way you succeed. And I want you to succeed. So, seeing almost everybody made 95% or better on the assignment on exponents, okay? Except for a couple of people that didn't do it. And same thing on the assignment of fractions. I didn't test you on that today, but you can expect it. Okay. If you're getting the right answers, but can't come in and do it in class, then you're not approaching it right. And we've got to figure out why. Okay. And I saw a lot of that. And not just in pre-calculus, more advanced courses. Linear algebra course is a pretty advanced course. You've got to have calculus behind you before you can do it. Okay. And linear algebra students, same things happening to them. It's online stuff. I find it questionable, but other people seem to think that it works. So that's what we're doing. Okay. Now, when I get to section 1.1, which was due yesterday, I think, maybe it's due today. 1, 2, 3, 4, 5 people did it. And I had some trouble with it. Not a lot of trouble, the scores around at 70%. What I'm seeing. Okay. So that's not terrible. It means you're getting most of it, and there's some things we need to look at. And we're going to look at them. Let me look at one more thing here. Yeah, looking at the exponents, just to make sure that I'm saying it right. The negative exponents were right there in one of those videos you were supposed to watch, and everybody says they did, but a lot of people didn't. Okay. People get their points quick by claiming that they watched the video, but then come into class and don't know how to do it. Okay. Don't be that person. And if you have been, it's okay. You got time to get over it, but not a lot. So get on the ball. Okay. A little bit about domain area. One at a time. Don't write them all out. Just write the first one out and tell me what you think the domain is. Then write the second one out. Tell me what you think the domain is. I want to see these kind of quick ones. Not everybody will get all four. I don't want you to waste time writing them all down if you're not going to get to it. But I'm not going to give you a lot of time. Okay? Let's see if you can tell me what the domains of these things are. Okay, so you want to look at the idea of domain. Okay. So you got y equals 1 over x minus 3. Well, x is 3, y is 1 over 0. If you think 1 over 0 has a value, tell me, how do you count to 1 by zeros? You count to 1 by 1/4, 1/4, 2/4, 3/4, 4/4. That's 1, right? Or 1/4, 1/2, 3/4, 1. Okay, you can count to 1 by tenths. 1/10, 2/10, 3/10, 4/10, 5/10, and so forth. Try to count to anything by 0. What do you get? 0, 0, 0, 0. You never get anything. Doesn't matter how many zeros you got, you're not going to get 1. Okay? That makes sense? You want to understand that. It's going to be very important when we look at asymptotes of some of these functions. You want to understand not just that there's a rule that you can't divide by 0, but why can't you divide by 0? First thing you do in the calculus class is limits. Things approach 0 in negative division. You have to understand what division by 0 means and why you can't do it. Okay? But if your number is close to 0, you get a big result. Well, those are important things. Right now, you got to know that you can't divide by 0 because you can't count anything by 0. Okay? This is how you find. The 3 isn't in the domain. Now you're going to express the domain by an interval notation, but we're not going to do that just yet. Okay. Y equals square root of x. What numbers can we not use for x? Okay, y equals square root of x. Again, square root of 25. What's the square root of 25? It's 5. What is that? 5 times 5 is 25. That's what the square root means. Okay? If this was negative 25, then you might want to say, well, the square root is negative 5. That wouldn't be right, because what's negative 5 times negative 5? It's 25. It's not negative 25. Okay? You can't get a negative number by squaring a number, so a negative number doesn't have a square root. I'm going to say squaring a number. Never gives us 0. Yeah, that's totally wrong. You can square 0 and get 0. Never gives us negative. Whatever number you square, you can't get a negative number. The square root of negative doesn't exist. That's after negative. Now, similarly, The square root of a negative doesn't exist, so x minus 4 can't be negative, right? So x minus 4 has to not be negative. So x minus 4 has to be greater than or equal to 0. And that's a simple inequality that you solve by adding 4 to both sides. So x has to be greater than or equal to 4. Make sense? Okay, now, tell me what you think about this. Write it down. See how you're doing with it. See if you're picking up the idea. Okay, so we have a little trouble getting started on this. So let's just look at two things. What numbers can't this x be? And what numbers can't this x be? Okay? What numbers are impossible? Look at each expression in turn and see if you can identify the numbers that are impossible. So I'll say that x values aren't usable. But x values can't you plug in here and expect to get a real number result. Okay. So let's write this expression out a little bigger. If you understand what was set up here, you know that this can't be 0, right? You can't divide by 0. You got 0 here. You don't have 0 up here. You have the square root of 2, which is about 1.4, 1.414. I don't know what goes after that. Okay. You got a number up here. So if x is 0, you're trying to divide the square root of 2 by 0. You can't divide by 0 because you can't count to anything by 0. You can't tell me how many zeros it takes to make up another number. Another way of saying it. Okay, well. This can't be negative, this can't be the square root of a negative. If nothing, you can square to give us a negative number. And you want to be sure you do your best to understand what I just said. So x plus 2 has to be greater than or equal to 0. Well, to do the algebra, x plus 2 minus 2 has to be greater than or equal to 0 minus 2. For solving for x. You can solve it the same way we do inequality, except if we multiply or divide both sides by negative, the inequality has to reverse. That's something you learn early on. Okay. Then you might have forgotten for a while. So x has to be greater than or equal to negative 2. And you can see that. You know, if x is negative 1, well, negative 1 plus 2 is just fine. Here's your 1. Square root of 1 is 1. Okay. If x is equal to negative 2, well, that's fine, but gives it square root of 0. You think about what's happening to the numbers. If you go below 2, you're going to get a negative. Okay? There it is. So x has to be greater than or equal to 2. Okay? So x has to be in the interval from -2 to infinity. And if you're not familiar with interval notation, that's easy to understand. Should be at this point, but it's quite been a while since I saw it. And it's going to be explained. So we'll let open math take care of that. And also x can't be 0. Okay, got to have both of these conditions. Well, at this point, it helps to draw this on the number line. Here's the x-axis. Here's -2. Okay. Can't be less than -2, so everything from here on is not going to be in the set. So the interval from -2 to infinity be from here on to forever. And of course, x can't be 0 either, right? So 0, whatever it is, has to be excluded. So you can't use 0. So you can use anything from -2 up to 0 and anything from 0 to infinity, right? So the domain all the numbers from -2 up to 0, not including 0. We don't include 0, so we don't use a square bracket over here. We use a parenthesis, right? So we can use -2. That's perfectly all right. You get 0. Square root of 0 is 0. And 0 over -2 is 0. So it's -2, 0, but we can't use 0, so we've got to split this big interval in half. And half that we split at x equals 0. We say it's the union of this interval and the interval from 0 to infinity. Now, infinity is not a number, it's something you can approach. Okay? So we don't put a square bracket on infinity because you can't get them. It can't be included because you can't get them. So we always use an open bracket on infinity or negative infinity. Okay? So that's how you do this. Okay? And in the homework, they don't get much more complicated than that. It's usually you can't have a 0 in the denominator and you can't do the square root of a negative. Those two things will get you through most of the problems.